discrete distribution. What is a discrete distribution? I told you about the discrete distribution. So most of the type of probability distribution is what? Basically, they just try to, carefully observe your quantitative numbers, or in a way that you can say that, let's say in your data, there are multiple various types of observations in a numeric form. So this distribution just try to convert try to find out the probability that each observation will appear again. Okay. And then this way just try to associate probability with each and every observation, and then identify the pattern and make some possibility and throw some possibilities. That's what the job of distribution theory is. So if the numbers are like descriptive, then we have studied that the binomial distribution, Poisson, and the hypergeometric distribution can be useful. Again, in certain circumstances, all the distributions, they have their own assumptions, they have their own characteristics, and if that characteristics and the assumptions are applicable in your practical problem, then you can think about fitting of that distribution in your data. Okay. So if you ask me that in the real, let's say while dealing with the real life data, how can we identify the fitting of appropriate distribution? So my answer is, you should know the properties, the characteristics of each and every statistical distribution theory. And if they match with your problem, then you just at least then you can at least think about fitting of those distribution. Okay, a particular distribution in your data. Now continuous, when the data is like continuous, it's not a discrete figures, or let's say your data file is full with the continuous observations, then there are certain observations page. Okay, yes. Usha Kiran is asking that I'm requesting you to solve the demonstrative problems from the book only. Last time I got some suggestions that if I can at least discuss some examples outside the book, that's why I have chosen to discuss the problems outside the book. And you're asking me to solve the problems which are given in the book only. I'll try to discuss both. Okay. Because there are a variety of opinions from your classmates, so I need to at least okay. Piyush is asking that outside the book is better. It's okay. I'll try to at least consider both the type of example. Don't worry about it. Okay. Both the type of examples I'll at least discuss. Don't worry about it. Okay. So part B is just chapter 5 is divided into two parts. As I said, that discrete distribution deals with the discrete figures, and continuous distribution deals with the continuous figure. Now, if you may ask, Acha, if you ask me very basic question, ये discrete or continuous है क्या? So I'll answer like this way. If you ask me what is my age, and if I answer, let's say 32 years, I'm 32 years old. So 32, okay, that's a discrete figure. And if you ask me that question again, if I say that my age is somewhere between 30 to 35, that's called continuous observation. Okay, so it's a very simple thing. So that's how you can at least discriminate between discrete and the continuous figure. Okay. Now let me just go to the part B, because we need to discuss the continuous distribution. Last time we have discussed uniform distribution, and this is a uniform distribution. So let's take one example from here. Okay. As an example, suppose a production line is set up to manufacture the machine. Okay. Let me just please increase the font size so you can at least read it properly. So as an example, suppose a production line is set up to manufacture machine presses in lots of 5 per minute during a shift. Okay, in one shift, you can imagine that they are manufacturing a particular lot of presses. Okay. when lots are weighed, the variation among the weights is detected with a lot of weights ranging from 41 to 47 grams in a uniform distribution. So in this example, A equals to 41, B equals to 47, and the length of uniform distribution is this. Okay. Again, so this is like very much useful in let's say product testing, or the let's say life testing also. This is like very important, because there's a particular branch of statistics called reliability and life testing. Okay, very well applicable in uh, production houses, so or the manufacturing firms. So in a manufacturing firms, let's say if you are concerned about the exact size of, let's say you are manufacturing, here they have said that machine brushes they are manufacturing. Let's say they are concerned about the weight of it. Okay, they have set the standards for the weight. Okay, but now let's say exact weight is sometimes it's not possible. Okay, they need to cross check whether the weight is as per their prescription or not. Okay, so when they just measure the weight after manufacturing the item, okay, in a one production run, they found it there is a variation in the weight of items taken from one particular production run. Okay, so they say that uh, the range of variation in the weight starts from 41 to 47. Okay, so we can say that 6 gram is the discrepant. 6 gram is the allowable limit. Don't label it allowable limit, but noticeable variation. 6 gram is a noticeable variation. Okay, so again, if you want to understand that, okay, what is a probability that randomly if you pick any item, the weight could be 42 to 43. Okay, 42 to 43. Without inspecting that item, without measuring the weight of, let's say, random item, what are the chances that the item's weight would be between 42 grams to 44 grams? Okay, so for that, it's already been given that the maximum possible weight could be 47 and minimum weight could be 41. The discrepancy is of 6 grams. So this way you can decide the height of the curve. So height of the curve is nothing but this way. This is the curve. Here 41 comes, here the 40, you can at least place 47. The height can be of 6, 1 by 6, 1 by 6. Okay, 1 by 6 is what basically? What is 1 by 6? Can you tell me the 1 by 6? What is 1 by 6? So this is 1 by 6. Okay. So here the probability, here normally probability figures, normally we just mention on the y-axis, we just mention the probability figures. On x-axis, we just take the observations. Measured weight. Okay, so what are the chances that, let's say if we choose randomly, if from that production done, if we randomly choose some items, what are the chances that its weight is between 42 to 44? So that can be answered through this. So maximum, so expected high value is 44 in this case, expected low value is 42 in this case. Now observed, if we talk about the observed probability that random items weight is between 42 to 44. This is how normally we write mathematically, that random items weight is between 42 to 44, and then the observable high is 47 and observable low is 41. So this is how you can at least get the answer. Tell me the probability. what it could be. So based on this, MCQs can be formed. 2 by 6. I mean, tell me the figure actually, proportion value. 1 by 3, 0.33333. Okay. So let's say based on this, let's say you'll be given a problem description and these are the options. Choose the correct option for the given probability. So for this expression, when random articles weight is between 42 to 44, tell me the probability. So this way, some MCQs can be formed. Okay. But if you draw the curve, then it's like very clicky for you. I mean, it's like very easy for you to understand. Okay, you can comprehend what exactly the probability you're looking for. Okay, so this is what I believe. Okay, now in real case, how this can be done? Let's say in a one production run, let's say you are okay. Say for example, this is like sanitizer bottle. Let's say the weight. Let's say in one production run, let's say you are manufacturing 50 such bottles. Okay, 50 such bottles. Okay, I'm sorry, my drawing is like very bad, very bad at drawing. Okay, so let's say imagine that in one production run you are developing 50 such bottles, and let's say you are noticing the weight. Let's say the normal weight is 50 grams. It's supposed to be 50 grams. Okay, let's say if you observe the first bottle, second bottle, third bottle, fourth bottle, fifth bottle, sixth, 7, 8, 9, 10. Likewise, you have measured the weight of each and every 50 bottles of that production run, and if you find that the weight is like 50.3 grams and 50.04 grams and 50 let's say 2 grams and 50 point. So these are nothing but, if you observe this kind of data, then please perceive that this is a uniform distribution. See, there is no much variation in it. Okay. But again, for the minor things, you have to at least decide the maximum possible and the minimum possible. Let's say the maximum value here is, let's say 50.3 and the minimum is 50.01. Okay, so you can draw the curve 50.01 and 50.03. If you draw the bar chart of this, let's say here you just put 50 bottles. Okay, and here let's say their weights. So it's like almost same. There's a minor difference. Can you see? You'll observe a very minor difference. So this kind of bar chart you'll get based on this data. So you have to perceive that this is a uniform distribution. Uniform, you can think about the fitting of uniform distribution. Okay, I'm saying bar chart, but you have to understand the characteristics of graphs. Bar chart is what? Observation number, or let's say subject number versus weights. Okay, subject number versus weights. This is a probability curve. Okay, this is a probability curve. Okay, in the probability curve, now the lowest possible observation is 50.01, the highest one is 50.03. What is the difference between this? 1 upon 50.03 and 1 up minus 50.0 oh 50.3 and 50.01. Tell me the difference. 0.2 means 20%. Okay, so this fx equals to 1 upon b minus a. B is the largest value and a is the smallest value, which is 0.20. Now you just tell me, if you pick up, let's say, bottle number 7 randomly, what are the chances that its weight is between, let's say its weight is between, let's say 50.1 to 50.2. Find out this probability. So mathematically we can write like this way. So try to understand. Yes, correct, correct. So mathematically we can write like this way. So probability that randomly chosen bottle, I mean seventh bottle, which is randomly chosen, its weight could be between 50.1 to 50.2 in a given circumstance. Okay. And this probability can be determined with the possible high minus possible low divided by observed high minus observed low. We can do it in Excel. We can do it in SPSS even. Normally, in a way that you are raising the queries, I don't get time to at least show you the XPSS. Otherwise, I could have shown. Okay. So chances are what? What 10%? Chances are 10%. Is it? Oh, sorry. It's 0.30344. Sorry, it's 0.344. So chances are 34.4% chances, and the probability is this. Okay. So this is how you should understand the uniform distribution. Got the clarity? Yes or no? Got the clarity? All of you? Are you clear with the uniform distribution? Sure? Now mean and the variance in this is, so standard deviation variance can be calculated like this way. So coming back to a book's example where they are discussing the weight of machine brass. Okay. Here what could be, because they are also measuring the weight. Okay, the maximum possible weight is 40, sorry, observable high weight is 47. Okay, and here the lowest weight that they have observed is 41. Now just tell me the mean of this, average value of this. Average value can be calculated like this way. So 41 plus 47 divided by 2, so it's 44. And standard deviation, can you calculate the standard deviation? It's 1.72. Okay, just like this. Got this? Now let me just discuss one more distribution with you. Now, characteristics of normal distribution. Now, what is normal distribution? Okay, so this is a few lines they have written for the introduction of normal, that the probability, probably the most widely known and used of all distribution is a normal distribution. I'll tell you why. It fits many human characteristics such as height, weight, length, speed, IQs, then scholastic achievement, and then years of life expectancy. Uh, After the life expectancy, among others, like the human counterparts, living things in the nature such as tree, animals, insects, other, and have many characteristics that are normally distributed. Let me just take you the simple example of normal distribution. What is a normal curve? Okay, let me just discuss with you. So as per the normal theory, As per the normal theory, what they are saying is, this is what they normally, if I discuss about the normal distribution, it was first discovered by English mathematician the Moivere, okay, in 1733, okay, 1733. So that was the English mathematician first discovered that. So this is what the mathematical function of calculating the probabilities in the normally distributed data, okay. The mean and the standard now I'll at least explain this terminology, don't worry about it. So in book they have mentioned that this is most widely distribution because in most of the real data, if you are studying the intellectual capability of let's say some people, let's say if you study some patterns in let's say plants and the animals, if you want to understand the behavioral aspect, if you want to study let's say the height and the weight of something, I mean some plants or the living organism, okay, then this is like widely let's say in many human characteristics, like okay, in many personality and the behavioral traits, they also use this very helpful, I mean this is a very helpful distribution. So this is like a normal, let me just take a simple example of this. Oh, this is a very bad curve actually. So let's say this is a normal curve. So let's say this is a grading pattern. Let's say A grade student. These are, let's say, a B grade student. These are, let's say, between B and C. This is, let's say, between B plus and A minus. And these are, let's say, D grade student. You can say. Let's divide A, B, and C. Okay. C grade, B grade, and you can say A grade students. Okay. So what exactly this is? I mean, if we can observe this, okay. So in a normal class, if the class is normal, okay, I'm talking about the normal class. I'm not talking about the abnormal class. In school days, we must have at least found some abnormal classes where the many of the students are like notorious and then they don't like to at least study and all that. Okay, but that's a joke actually. You just at least try to at least consider those kind of classes which are normal, I mean, so in which let's say less number of students are scholars, most of the peoples are like average students, and the duffers population is very less. Okay, this is also less, this is also less. Okay, these are the in the average students proportion is like very high. Okay, so this is normally we uh, normally we just at least find this kind of situation, okay, taking place if we let's say study any normal class. Okay, if we compare their IQ level, very few students IQ is like extraordinary, and at the same time very few students IQ is like very poor that we can't at least even compare with the rest of the class. And normally many of the people have moderate level of IQ, I mean. So what scientists, I mean the scientist who developed this normal concept said that, let's say whenever you at least plot the data on a piece of graph paper, and if you find that okay, this is an average value, this is average, okay, and let's say this area is average minus one time standard, average plus one time standard deviation. This is average plus one time standard deviation. Average plus one time standard deviation. This is average minus one time standard deviation. Okay. Okay. So if you consider this range, scientists say that if you find that 68%, roughly 68%, roughly, okay, the exact is 68.2%, okay, exact is 68.2%. If you find that roughly 68% people's data is falling in that particular region, then you can say that if you are studying their IQ level, their then it's normally distributed. Okay, any random class, if you choose, and if you find, if you, let's say, conduct a test which basically check their IQ level, and let's say if majority of the people, okay, fall into this range, I mean mu, this is called average minus sigma to average plus sigma, okay, majority, let's say if we quantify this majority, then approximately 68% people, fall into this region, then you can say it's a normal. Along with this, there is a second criteria which is telling us that, okay, if you consider this range average minus 2 times standard deviation and average plus 2 times standard deviation, then in this particular range, most of the, when I say most of the, 95 point, okay, roughly 95% people fall into this range, then you can say it's a data follows normal distribution. So this is how you can at least, by looking at the curve, many times you cannot decide, but you can just have some hunch about the normality. But this is how you can say that the data follows normal distribution. Okay, these are the three criterias. Okay, based on the placement of these lines called average minus 1 time standard deviation, average plus 1 time standard deviation, average minus 2 times standard deviation, average plus 2 times standard deviation. Some students are like outliers. They can fall outside this range. Okay, either they are like extremely scholar or let's say extremely poor. Okay, why? Because they say that the scientists said that average minus, when you consider this range called average minus 3 times standard deviation to average plus 3 times standard deviation, you can't expect 100% people's data for fall into that region. It's like 99.7%. You cannot be sure about 0.03% people. Okay, oh sorry, 0.3%, 0.03%, yes, you can't be sure about them. Okay, you can't be sure about 0.30% people. Either they could be extremely bright or let's say extremely poor. Got this? So these are the limits. Now this is what the structure of this is what the mathematical structure of normal distribution. Okay, now what is the range? Let me just define the range of it. So range is minus infinity to plus infinity. Okay, minus infinity to the plus infinity. So what is the advantage of this normal distribution? That captures almost all the numeric quantity. If the figures are in negative, if the figures are positive, if the figures are, let's say, zero with a 0 point, okay, all the numbers can be, okay, can be studied with the normal distributions. This is a very beautiful thing about the normal distribution. So this formula can capable to at least calculate the probability based on the observations, okay, and the past data if you are having. So this particular formula is capable to calculate the probability if your observations are negative, positive, fractions, integer, whatever it is. Okay. Now normal distribution is like so in this case standard deviation is like this decide the shape of the normality, and placement of the curve is can be determined by the average value. Okay, just remember this thing. I'll at least so here, because the normality curve's shape is dependent on the standard deviation value, and the placement of the curve or location of the curve is decided based on the mu. Mu is called, or the average value is called, location parameter, and the standard deviation is known as a shape parameter. Okay. Now, many times dealing with the actual observations is like very difficult, particularly when 30 years back people don't have, calculators. They had calculators, but they don't have the such software like 30 to 40 years back. So they used to calculate them manually. Okay, those kind of probabilities based on the normality table. But again, in that era when the computers and the softwares were not available, people used to find out some simple, simple techniques of calculation. So this is a simple technique. This concept is called standard normal distribution. So if you observe this normal formula, okay, if you observe this formula, so it's talk basically it's nothing but in the exponential part. It's like हर एक observation minus average value and divided by standard value, standard deviation. तो मतलब ये फिगर कोई भी होगा, चाहे वो जीडीपी हो, चाहे वो हाइट हो पर्सन की, चाहे वो आईटी स्कोर हो, चाहे वो लेट्स से किसी का सेटिस्फेक्शन लेवल हो सेटिस्फेक्शन सर्वे में. So whatever this observation is, whatever the range is, okay, so observation minus average value divided by normal deviation from average, normal deviation from average, this will standardize. Actually this is going to, this formula will standardize, or let's say transform the actual set of observation into new series, okay, which can be started from -3 to +3. Let me just give you a simple example. Let's say if we are studying GDP figures, and let's say the state-wise GDP figures, if we consider, and let's say this is just a simple example, okay, don't really apply your logic, okay, whether they are comparable or not. So let's say we have 37 states and union territories, okay, 37 states and union territories. Let's say average GDP is, let's say, $3 lakh. Imagine, okay, $3 lakhs. Just imagine. This is average GDP of a state, okay. Now let's say a particular state's GDP is, let's say, $4 lakh minus 3 lakh, and let's say normal deviation is, let's say, 1 lakh. Normal deviation is, let's say, 1 lakh. Can you tell me what this is going to be? This is going to be 1. And let's say when we are studying the height of the students, let's say in this particular class the average height of the student is, let's say, 5.2, and let's say somebody's height is, let's say, 5.8, and let's say normal deviation is, let's say, 0.2, let's say. Can you tell me this figure? So z is nothing but x minus mu divided by sigma. Here also this is x minus mu divided by sigma. So this way z is just trying to at least transforming the actual series into some different one. Okay, that's why it's called the distribution. Then it becomes the distribution of the standardized values. Okay, then it will become the distribution of standardized values, because we just try to replace the actual observations, okay, we just try to transform the actual observations into the z values. Okay, this variable, this actual observations range could be anything. If they are GDP figures, the figures could be in lakhs and crores, and if it is a height data, then the measurement of unit could be centimeters, or let's say feet, and the inches and something. If this is a weight of some items, then it could be kgs. If this is, let's say, measurement of liquid quantity, then it's the measurement is in the liters. But if you convert into the Z value, okay, all are comparable. So this is going to be the unit free. This is going to be the unit free. Okay. So that's why it's called standardize, because you just try to find out for each and every observation. You just try to figure out that what is the Z value for that observation, that particular observation minus mu divided by standard deviation. So Z value is a way of standardizing it. Okay. And the distribution of Z value is known as standard normal distribution. Again, here the ranges would be different. So this is a particular value. Let's say my height is 5.8. Imagine, okay, it's not. Let's say my height is 5.8 and the average height in this class is, let's say, 5.8. What is going to be the Z value now? 0. Okay. So when the observation value become exactly equal to the average value, okay, so that's a measure of central tendency. Average is a measure of central tendency. So mean equals to 0 and the variation is, let's say, 1. You can consider it, the variation is 1. So this is 1, this is minus 1, this is 2, minus 2, this is minus 2, and the biggest possible value in Z standardization is minus 3 and minus 4, or minus 3 and plus 3. Okay, again the same rule will be applicable. Minus 1 to plus 1, if you find that 68% data, 68.26 data points are falling, and let's say minus 2 to plus 2, let's say 95% data points are falling, and let's say in the third category, let's say minus 3 to plus 3, let's say 99.73% data points are falling, then you can say that data follows normal distribution. But exact normal distribution is like not possible in the real world. Why? Let's say you're dealing with one particular data, and here, let's say, instead of 68.26, let's say 67.9% data points are falling, and here, let's say 94.28% data points are falling. Here, let's say 97% data points are falling. Can't you say this is a normal distribution? Can't you say this is a normal distribution? Can you say this is a normal distribution? Imagine that I am studying the age, I'm dealing with the age data of this class. Let's say I have asked your age, individual. Let's say I have asked that question to each and every individual in this class, that what's your age? Okay. And then I found that कि -1 से +1 मतलब